and then cubed root of negative x under the radical. I also thought of, that's right, you could also have stated that instead of reflecting over the y-axis, you might have seen it as a reflection over the x-axis. So let's see what that would look like. If I reflected this point over the x-axis, that would put me here. If I reflected this point over the x-axis, that would put me here. So that would be the same points that I got when I reflected over the y-axis. So with cubed roots, whether you reflect over the x-axis or the y-axis, you get the same thing. But in your equation, you have to reflect whatever you write in your description has to also match your equation. So if you say that it's reflecting over the y-axis, then the negative should be on the inside. If you say that it's reflecting over the x-axis, then the negative can be on the outside with the 2. And then the x underneath would not be negative. So that's either one of those would be acceptable answers. Although if we did simplify this, it would end up being negative 2 out front anyway. Okay, so hopefully that made sense. No, the next one, we have a fifth root. A fifth root is very much like a cubed root. You're going to use negative 1, 0, 1. You get negative 1, 0, 1, but it's just a little bit more boxy than a smooth curve. It's a little bit more sharper of a curve in there. But we'll still graph the parent. And again, when we take the fifth root of negative 1, 0, and 1, we get negative 1, 0, and 1. Now be careful where your x-axis is down here. So negative 1 is here, 0, 0 is there, and then 1, 1 is here. And it's going to kind of have the same shape. So now we want to compare. Well, if we look at the middle point here, the center point here, it looks like it's the whole thing is shifting up 2. So if we moved all the points up 2, if we moved this one up 2, it would be here. If we moved this point up 2, that would put us there. So just shifting up 2 is not going to equal the same thing. But we also then can, hopefully you can see there's a stretch. So this point, instead of it's being 1, 1, or having a rate of change of 1, 1, it's 2, 1. So instead of rise over run, think rise over run, up 1 over 1, down 1 over 1, it's up 2 over 1, down 2 over 1. So that's going to be a vertical stretch by a factor of 2. Now, how would you know for sure? Let's say you think you're correct, but you're not real sure. So if you say that there's a vertical stretch by a factor of 2, that's going to affect the y-coordinates. And you would have to multiply, if we multiply the y-coordinates by 2, and then we also had a vertical translation or shift up 2. So not only did we have a vertical stretch, so vertical stretch by 2, but we also have a vertical translation up 2. So we would have to add 2 to the y-coordinates. So I can check my points here, and I can check to see if I've got these things right, if this works. So notice the x-coordinates don't change. So I would have negative 1, 0, and 1. But my y-coordinates, if I multiply by 2, would give me negative 2 plus 2, which would be 0. 0 times 2 would be 0, plus 2 would be 2. 1 times 2 is 2, plus 2 would equal 4. So now let's see, do we have these points on our graph? Negative 1, 0 is right here. 0, 2 is right there. 1, 4 is right there. So that's also confirming, yes, these are the correct things. All right, so now as far as writing the equation, the vertical stretch by a factor of 2 is going to go in front of our equation and get multiplied. The vertical translation up 2 is going to go at the end of our equation, and that's going to be a plus 2 at the end. But what's going to go here? Well, what did you start with? The fifth root of x. So that's exactly what you're going to have here. There are no changes to x, so there won't be anything on the inside. The 2 being multiplied in front stretches it vertically. The plus 2 at the end makes it go up 2. So that is your equation. Okay, the next one. Now we've got logs. So with a log, you need to look at your base. Well, if there's no written base, then the unwritten base is 10. You cannot substitute -1 and 0 in your log. So instead, we use the base. And we can use, the way I've been teaching it is start with the reciprocal or the inverse of your base, which would be 1/10. And then always use 1. You can use 1. And then the base itself, 10. So if you think about 1/10 and you plug it in here and you think to yourself, it's going to equal y. So f of x is basically y. So 10 to what power would equal 1/10? So your answer to that would be -1. If we put the 1 in here for x, think 10 to what power would equal 1? 0. If we put 10 in the place of x, think 10 to what power would equal 10? 1. So the -1, 0, and 1 become your y coordinates instead of your x coordinates. So graphing these original points, look at where here's your x-axis, here's your y-axis. So 0, 0 is here. So 1/10 means go to the right a tenth of a space and then down 1. 1, 0, and then 10, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. It's just a little bit off the graph. And there will be a vertical asymptote of the y-axis. So that's our parent. So what's happening? Well, if we look at the vertical asymptote, your whole graph looks like it's shifted over. The vertical asymptote is shifted over 2 spaces to the right. So we definitely have a horizontal translation to the right too. So horizontal translation to the right too. But besides that, our graph is also flipped the other way. So there's got to be a reflection over the x-axis. All right, so let's say we take this point, we reflect it over the x-axis. That would put me here. If I move it to the right too, that would put me here. So that looks pretty good. If I took my 10, 1, if I reflected that over the x-axis, that would put me here. And then to the right too, that's going to be hard to see if that's on the graph. So let's look at the point here. You can't really reflect, if it's on the x-axis, when you reflect it, it doesn't make any difference. But if we move to the, this is by units of 2. So then this would be, if this is 2, then this is 4. This should be labeled better. Okay, so that 2 tells me these are going by units of 2. So this is 2, 4, 6, 8, 10, 1. So 2, 4, 6, 8, 10. But the y coordinates are going by 1s. So 10, 1 would actually be there. Yeah, that's something that... So if that's 2, that means that this is 4. And then this would be 6 and 8 and 10. So instead of a horizontal translation to the right 2, it's going to be a horizontal translation to the right 4. Okay, so all right, going back to checking. So if this actually is true, the horizontal translation to the right 4 would affect the x coordinates. So if I added 4 to all of my x coordinates, would I get the correct points? Well, let's see. If we reflect it over the x-axis, that means our y coordinates are going to be affected, and we would multiply the y coordinates by -1 to get our new coordinates. So let's see if these points that we get match up with what we should be getting. So the 4 plus 1/10 would be 4 and 1/10. The 4 plus 1 would be 5. The 4 plus 10 would be 14. Negative 1 times negative 1 would be positive 1. 0 times negative 1 is still 0. 1 times negative 1 is negative 1. All right, so 4 and 1/10. So if this is 0, 0, 4 and 1/10 would be just a smidgen over, and then up 1. That looks good. 5, 0 would be, that would look good also. And then 10, 12, 14, negative 1 would be right here. So those points actually do match up with our new graph. So we do, so that's a good way of checking to make sure that you've got your transformations correct. Now, as far as writing, the horizontal translation of the right 4 is going to affect the x-coordinate, but the reflection over the y, or the x-axis, affects the y. So that reflection over the x-axis means we have to have a negative 1 in front being multiplied times our original equation, which was log of x. But that x gets affected also. In order to make the function go to the right 4, you have to subtract 4 and make sure that that is in parentheses. If it's not in parentheses, then it's going to be a k value instead of a h value. So make sure that's in parentheses. So negative 1 times log parentheses x minus 4. And the base we didn't have to do anything with because it was 10, which is the unwritten base. All right. Next problem. So we've got e to the x power. Since it's exponential, we can plug in negative 1, 0, and 1. E to the negative first power is approximately 0.4 when you round it, but you can plug it in the calculator if you forget. Anything to the 0 power is 1. And then e to the first power is approximately 2.7. There will be a horizontal asymptote on the x-axis this time. So when I graph it, negative 1.4 is going to be about right there. 0, 1, and 1, 2.7 is going to be about right there. So that's my parent, or f. So it looks like it's flipped over the y-axis and it's shifted up 2. That's what it looks like. Well, let's see. If I reflect it over the y-axis, that's going to affect the x-coordinates. So I would multiply the x-coordinates by negative 1. And then it looks like this point is simply going up 2. So let's try, if I make it go up 2, I would have to add 2 to the y-coordinates. So I'm going to see if that works. If it doesn't, then we'll start over. So the negative 1 times negative 1 will be positive 1. Negative 1 times 0 is 0. Negative 1 times 1 is negative 1. 0.4 times plus 2 would be 2.4. 1 plus 2 would be 3. 2.7 plus 2 would be 4.7. So hopefully these points work. 1, 2.7. If I go to the right 1 and up 1, 2.7. Oh, 0.4. To the right 1 and up 2.4. That does look like that matches up. 0, 3 is right here. Negative 1, 1, 2, 3, 4.7 is right there. So that does work out. So we do in fact have a reflection over the x-axis and a vertical translation up 2. All right, so how do we make this look in the equation? So the reflection over the y-axis, since it affects the x-coordinate, it has to be up here in the exponent with the x. So you're just going to put a negative with the x in the exponent. And then making it go up 2 means you're just going to have a plus 2 at the end. So your equation will be e to the negative x power plus 2. And there you have it. All right, the next one is also exponential, but this one looks like it's exponential growth or decay because it's 1/4. So if I start with it's a different color. My parent, I'm going to plug in negative 1, 0, and 1. So 1/4 to the negative first power is going to be 4. Anything to the 0 power is 1. 1/4 to the first power is 1/4. Graph those points. Negative 1, 1, 2, 3, 4 would put me here. 0, 1 is there, and then 1, 1/4 is right there. So, let's see what's going on. It looks like they still have the same horizontal asymptote, but from this point to this point, or maybe it's just going up 1. Let's see. No, because if this was going up 1, then this would be going up 1 also, which doesn't match up. So maybe it's a horizontal stretch. I think that's what we got going on here. Or no, because if we had a horizontal stretch, this one would go this way. Unless I graphed that wrong. So -1, 1, 2, 3, 4. So maybe it's a vertical stretch. There we go. If I go from here to here, instead of up 1, it's up 2. So 1 times 2 would be 2, which would make sense because if I multiplied this y coordinate by 2, it would be 8, which is off the graph. If I multiply this y coordinate by 2 instead of 1/4, it's going to be 1/2. So I think that does make sense. So if I multiply my y coordinates by 2, my x coordinates would stay the same, -1, 0, 1, but my y coordinates would be 8, 2, and 2, 1/4 times 2 would be 1/2. So does that match up? Well, -1, 8, like I said, is off the graph. 0, 2 is right here, and then 1, 1/2 would be about right there. So that does work out. So we have just a vertical stretch by a factor of 2. So that just means I have to multiply the equation by 2 in front, and then the 1/4 to the x power does not change. So there's my equation. All right, moving on. Next page. Okay, sorry. So here we have our rational equations. So with the rational equations, most of the time we're just focusing on the h and k, but remember, what does h do? H makes the graph move left and right. K makes the graph move up or down. So if we look at where 0, 0 is, so here's the x, so this is my x-axis, this is my y-axis. So if I look at this graph, it looks like it's shifted to the left and down a little bit because the parent would be here and there. So this would be our parent. Well, how do I know that? Well, the parent, even though we didn't write it down, so the parent for these would just be y equals 1 over x. So if I substituted -1, I would get -1. If I substituted 0, that would give me my undefined value, which is my vertical asymptote. If I substituted 1, I would get 1. So the 1, 1 and the 1, -1, -1 would be those 2 points, and then you'd have your branches going out. So if you look at this whole thing, the whole thing is moving to the left and down. Also, if you look at, where's it merging to? It looks like it's merging to that vertical line and this horizontal line. So we need to just figure out, well, what x coordinate is that? So from 0, 0, it's going to the left 1, 2, 3, 4. So if you're going to the left 4, then h has to be -4. Where is your y? Where's this going down? How far is this going down? 2. So if the whole thing's going down 2, then your k would be -2. So your vertical asymptote cuts through the x-axis. So vertical asymptotes are always x equals, And what does the x equal? -4. So all the points on that line have an x coordinate of -4. Horizontal asymptote is always y equals. So if we look at what does y equal when it crosses? -2. So all those points on that horizontal asymptote have a y coordinate of -2. Domain and range kind of go hand in hand with all this, so it's going to be all real numbers except when x equals -4, and all real numbers except y equals -2. So that would be your domain and range. Next one, we have, again, want to look at the vertical and horizontal asymptotes. And we want to maybe darken our x and y axis. So here's the x, so that means this is my x axis, this is my y axis. So looking at this hyperbola, it looks like my vertical asymptote shifted to the right 1, 2, 3, 4, and up 2. So if it's going to the right 4, then your h is going to be +4. If it's going up 2, your k is going to be a +2. And your vertical asymptote will be x equals 4, horizontal asymptote y equals 2, domain all real numbers except x equals 4, range all real numbers except y equals -2. All right, and I was just looking at the directions. I guess for these you just had to state whether it was positive or negative, so I guess both of these were positive and both of these were negative. So if you just put positive or negative, that's fine. If you put the numbers, that's fine, as long as you show the signs also. Now the last one here, again, let's focus on your x-axis. So it looks like the x-axis is here, although all of these have the x below the x-axis. So let me double check that. That one's kind of tricky. Yeah, it is supposed to be here. And your y-axis is here. Sometimes it's hard to tell when you copy these things. So it looks like our horizontal asymptote is going to be the same. It's going to be at 0. So it's not moving up or down, but it is going to the left 2. So our vertical asymptote is shifting over to the left 2, but it's not moving up or down. So left 2 means h equals -2. Since it's not moving up or down, you would have k would be 0. So your vertical asymptote, this one here, is x equals -2. The horizontal, it would just be y equals 0. And domain, all real numbers except x equals -2. Range, all real numbers except y equals 0. All right, so those are the rational functions. That's a lot of problems. Number 12. Find the inverse function and state the domain and range of both. All right, so with inverse functions, if it's just a regular equation like this where f of x and x or x and y, you just want to exchange the x and y's and then solve for y. If it's an equation where the variables have meaning, then you do not want to switch your variables. So keep that in mind. So f of x is basically y. So when I switch my x and y, instead of y equals, it's going to be x equals. Instead of -1/3 x, I'm going to have -1/3 y and then plus 5. What I might want to do though, this is kind of how I had this set up, I guess, for f of x, for the original function, to state your domain and range, look at what you originally have. So hopefully you recognize this as being a linear equation, and a linear equation that has a slope of something that's not 0 would have a domain of all real numbers and a range of all real numbers. So it's basically a diagonal line. It's going to keep going up and down forever and ever, and left and right forever and ever. All right, so going back now to the inverse, I'm going to keep solving now for y. So I flipped my variables. Now I want to get the y by itself. Subtract your 5, and I'll have x minus 5 equals negative 1/3 y. To get rid of the negative 1/3, I'm going to multiply by the reciprocal, which is negative 3. Alright, so when I multiply both sides by negative 3, on the left side I'm going to have negative 3x plus 15. On the right side, the negative 3 times the negative 1/3 basically just becomes 1, and then we have our y by itself. So instead of y now, we're going to call it either g of x or f inverse. I guess I have it set up as g of x. So I'm going to say g of x equals negative 3x plus 15. So this is my inverse function. It's again a linear equation. It has a slope, which means domain is going to be all real numbers and the range is going to be all real numbers. B. If we look at what we're originally given, we have a square root equation. So a square root has a root of 2, which is even, which means we can have 0 under here, but you cannot have a negative number. So your domain has to be greater than or equal to 0. The range, though, is going to start at your lowest point. So if we were to graph this, let me just kind of, the starting point would be going down 3. But because you have a positive 2 here, your starting point would be at negative 3, but the positive 2 means it's going to go up and to the right. So the lowest point on the graph would be negative 3. So your k, which is negative 3, and your a value tell you what's going to be, what your range is going to be. So the k value, your y is always going to be either greater than or equal to k or less than or equal to k, depending on if the graph is opening up or down. So since it's positive, it's going up, so y has to be greater than or equal to the k value, which is negative 3. Well, once you've got that domain and range, it makes it easier then to write the inverse domain and range because they just flip. You do still have to have x and y, but instead of x being greater than or equal to 0, in the inverse it's going to be y that's greater than or equal to 0. If in the original equation y is greater than or equal to negative 3, in your inverse x is going to be greater than or equal to negative 3. Now as far as writing the inverse, again we're going to switch the x and y and then solve for y. So this f of x is y. When I flip it, it's going to become x equals, the 2 is still in front. Instead of square root of x, it's going to be square root of y minus 3. Now I'm trying to get the y by itself, so I'm going to add 3. So that becomes x plus 3 on the left equals 2 square root of y on the right. Then get rid of the 2 by dividing both sides by 2. So on the left, I have x plus 3 over 2 equals the square root of y on the right. And then to get rid of the square root, square both sides of the equation. But you have to square this whole thing. So that will get rid of that. So we could just leave this as x plus 3 over 2 squared equals y. So here, oops, I'm not even on the screen. All right, so going back again, we divided by 2, which gives us x plus 3 over 2, squared both sides to cancel out the square root. So just leave that whole thing written like that. It's fine. So we would say g of x equals x plus 3 over 2 squared. Now, if this was a standardized test, you probably wouldn't see it written like this. You would probably see it as 1/4 x plus 3 squared. Let me explain that. So the x plus 3 squared kind of makes sense, but the 2 squared would be a 4 at in the denominator. So if I factored that out or pulled that out, it would be 1/4. Would be then my a value in front. So either this written like this or like this is acceptable. Okay, and then the last one on this page, we have an exponential function. So for an exponential function, the domain would be all real numbers. However, your range, if you think about what the graph of an exponential function looks like, and this is exponential growth, it does have a horizontal asymptote of the the x-axis. So your range, your y-coordinates would have to be greater than 0, but they cannot equal 0. So y is going to be greater than 0 for your range. And again, thinking about these graphs and what the basic graph looks like helps. So then, now that we know that the domain is all real numbers, in your inverse, the range would be all real numbers. In the original, if y is greater than 0, then in the inverse, x is going to have to be greater than 0. All right, so now we got to write the inverse function. So once again, if this is y and we switch the x and y, instead of y equals, you would have x equals. 4 to the x power would become 4 to the y power. To get the y out of the exponent, you're going to have to do the log, take a log of both sides. And since this base is 4, you want this base to be 4 of x equals log base 4 of 4 to the y power. So we are taking the log base 4 of both sides of the equation. So the x here and the y to the 4th power, or 4 to the y power, are brought down there, and you're doing log base 4 to both sides of the equation. So this log base 4 and that base of 4 eliminate each other, so then we get y equals log base 4 of x. But again, instead of using y, we're going to call it g of x equals log base 4 of x. And make sure that the base looks like a base and not like a term. All right, so that does it for page 4. Almost done. All right, page 5. Number 13. Your friend releases a weather balloon 50 feet from you. The balloon rises vertically when the balloon is at a height of... All right, well, I mean, there's a lot of information here, but what are they asking us to do? They're asking us to find the inverse of the function. So since these variables have meaning, you do not want to switch them. You just want to solve for the other variable. So we want to solve for h. So let's take this equation, bring it down here, and try to figure out what are we going to do to solve for h. Well, h is underneath the radical, so we need to get rid of that radical. Well, how do we do that? Well, since it's a square root, raise it to the power of 2 on both sides. So that gets rid of your radical, or your square root. So now we have d squared equals 2500 plus h squared. Again, our goal is to get h by itself. So let's move the 2500 to the other side by subtracting it. So that will give me d squared minus 2500 equals h squared. To get rid of the square now, we're going to have to square root both sides of the equation. So that will cancel out. So on the left side of the equation, we would have the square root, and we took the square root of both sides of the equation, which means we should have a positive and negative. However, what does h represent? H represents the height in feet. So I'm guessing, so because it's a height, we don't have to worry about the plus minus, it's just going to be positive. So square root d squared minus 2500 is going to equal h, or we can flip it around, say h equals the square root of d squared minus 2500, and that whole thing is under the radical. So there's our inverse function. So now that we have the inverse function, part B wants you to use the inverse function to find the height, when the distance between you and the balloon is 100. So the distance is 100 feet. So D equals 100. So if we put 100 in place of D, we would have 100 squared minus 2,500. So 100 squared would actually be 10,000 minus 2,500 would equal 7,500. The square root of 7,500 is approximately, if we round to the hundredths, 86.60, and that is feet. So we found the inverse function, we used the inverse function, and that's what we had to do for that problem. That's it. Number 14. They're asking us to write an exponential function. So they're telling us what it's going to look like, sort of, but whose graph passes through the point 3,8 and 5,2. So with an exponential function, this is a lot like the geometric sequences that we were doing, and we had to write a rule for the geometric sequence. But instead of an r and an a sub 1, you're given an x and a y in your equation. So we're going to need to write two equations using both points. So this is going to be our x and our y for one equation. This is the x and the y for our other equation. So I'm going to temporarily substitute 8 for y and say that that equals a, which we don't know, times b, which we don't know, to the x power, or to the third power. At this point then I would solve for a in my first equation. So divide by b to the third, and then I would get 8 over b to the third equals a. Another way you could express this is by saying 8b to the negative third. So if you wanted to make this just one expression and not have the denominator, you could put that in the numerator but make it an exponent of, that's negative 3 instead of positive 3. Alright, so that's this first equation. So now I'm going to write the second equation. So the second equation comes from my second point. Again, you're going to plug in the y coordinate for y. So it's going to be 2 equals a and b we don't know yet, and the x coordinate is 5. So that's going to go in the exponent. But now instead of solving for y, I'm going to, or instead of solving for a, I'm going to substitute what I had gotten for a earlier. So my a equals 8b to the negative third power. So I'm going to plug that in for a here. So 2 equals 8b to the negative third power is what you're putting in place of a, and then times b to the fifth power. So your b to the negative third power and your b to the fifth power, when you multiply them, you add the exponents. So our new equation would be 2 equals 8b squared. Negative 3 plus 5 equals 2. Now it's a matter of solving for b. Divide by 8, and we get reduce that would be 1/4. So b squared would equal 1/4, and then take the square root of both sides, and b would equal a positive and a negative. Square root of 1 is 1. Square root of 4 is 2. So b would equal a positive or a negative 1/2. Okay, just looking at my notes here. So in an exponential equation, your base cannot be negative. So we can disregard the negative. And it's just going to be the positive value that we're going to use. So our base is just going to be 1/2. Doesn't want to erase. Okay, so our base is going to be 1/2. All right, well, how do we find a? Well, over here we had an equation for a. A equals 8 divided by b to the third. So if I use that equation, a equals 8 divided by 1/2 to the third power. So if I simplify that, 1/2 to the third power is actually 1/8. Well, when you divide a fraction, you could multiply by the reciprocal and the reciprocal of 1/8 is 8. So 8 divided by 1/8 is actually going to equal 64. So that's our A value. Well, now that we have A and B, we can now write our equation. So our equation then is going to be y equals, in place of A, you're going to put 64. In place of B, you're going to put 1/2 to the x power. So that is the equation. Okay, and the next problem says use the given values to write an equation relating x and y if they vary inversely. Then find y when x equals 3. So you're going to have two things to do. You have to write the equation, then find y when x equals 3. So let's forget about this finding y when x equals 3. Let's just write the equation. So if your equation varies inversely, there's going to be a constant product. So that constant product we had called A equals x times y. So the given x and y value that the x and y value that you're given is -12 and 2/3. So A is going to equal -12 times 2 would be -24, divided by 3 would be -8. All right, so now that we know our A value, you have to remember, well, what does the inverse variation equation look like? Y equals A over x is what the equation looks like. So if we know that A equals -8, then our equation is y equals -8 over x. So that's your answer to the first part. That's your equation. Now we're going to use the equation to find y when x equals 3. So y equals -8. You're going to substitute 3 for x. And since that cannot be reduced, y just equals -8/3. And that's all you had to do. All right. The next one is from chapter 7. It's an arithmetic sequence. So an arithmetic sequence, your equations are, the rule is a linear, it looks like a linear equation. But instead of calling it a slope, they call it a common difference of d. The equation, or the formula, is, so if you're writing a rule for the nth term, the formula for that is a sub n equals a sub 1 plus n minus 1 times d. Well, the n is your input. The a sub n is the output. So if you look at what they're giving you here, n is going to equal 13. A sub 13 equals 42. So your a sub n is you're going to replace 42 for a sub n. So the 42 replaces the a sub n. A sub 1 we don't know. N is replaced with 13. And d is replaced with 4. So in this problem they told us what d was. When I subtract this, I get 12 times 4 would be 48 plus a sub 1 equals 42. So to solve for a sub 1, subtract 48. So that 42 minus 48 would be -6, then equals a sub 1. So now that I know a sub 1 and I know my d, I can rewrite this equation, bringing the n back, but plugging in -6 here and 4 there. But you do need to simplify the equation at the end. We don't want it to just be in this format. So again, a sub n would equal, instead of a sub 1, -6 plus n comes back into the equation, -1, and then times your d, which is 4. So now simplify that, distribute the 4, and you get -6 plus 4n minus 4. And then combine like terms, put the 4n in front, and then -10. So a sub n would equal 4n minus 10. All right, so there's our rule. In the next problem, now we have a geometric sequence. So with the geometric sequences, the rule for the nth term of a geometric sequence is a sub n equals a sub 1 times r to the n minus 1 power. So here they don't tell us either one. We're going to solve this basically the same way as we did the exponential equation back in problem 14. So this one's very much like the exponential problem in 14. Our a sub n, so this is the a sub n, and this is n. We're going to write two equations, one with each of those terms of the sequence. So 63 is going to equal a sub 1, which we don't know, r, which we don't know, but the n is going to be replaced with 3, so 3 minus 1 would just be 2. Again, I want to solve for a sub 1 by dividing by the r squared. So my a sub 1 would equal 63 over r squared, or you might want to say 63r to the negative 2 power. Now do the same thing with the second term. So the 6 now is going to be our n, and the negative 1701 you're going to replace the a sub n with. So our equation, negative 1701 equals a sub 1, which we don't know, r, which we don't know, to the n minus 1, or 6 minus 1 power. Oops, that's off the picture. So that's going to be 5. So negative 1701 equals a sub 1 times r to the 5th. But now we want to substitute that a sub 1. So in the other equation, we had said a sub 1 equals this or this. So if I take this expression and substitute it for a sub 1 into the other equation, I'm going to get 63r to the negative 2 power times r to the 5th power. Again, when you're multiplying things with the same base, add the exponents, and you get negative 1701 equals 63r to the 3rd. Now we need to solve for r. Divide by 63, and that's going to equal negative 27. So negative 27 equals r to the 3rd. Now we can take the cubed root of both sides of the equation, which will equal negative 3. So r is negative 3. Now you can plug it back into this expression or this expression. I would probably plug it into the first one here. So my a, so I'm going to plug it in here. So a, I don't want to use up too much space. I'm going to go over to the left here. A is going to equal 63, helps if you can see it, over negative 3 squared. So we're substituting negative 3 in for r. We're squaring it, which is going to make it a positive 9. And then that tells me that a sub 1 is going to equal 7. So now that I have my a sub 1 value and I have my r value, I can write my rule for the nth term. So I'm going to do that off over here. Zoom out a little bit so you can see it. So my nth rule, a sub n equals a sub 1, which is 7, times r, which is negative 3, to the n minus 1 power. All right, there we go. Number 18. In number 18, you are finding the sum of this expression when k is between 1 and 6. This is not something that we have a special formula for, which means we're going to actually substitute 1 through 6 in the expression and then add the outputs together. So I'm going to make a table. So this is going to be my k, and then k squared minus 2k. So if I plug in 1, 2, 3, 4, 5, and 6. So 1 squared minus 2 times 1. Well, 1 squared is 1, minus 2 is negative 1. If I plug in 2, squared it minus 2 times 2, 4 minus 4 would equal 0. Substitute 3. 9 minus 6 would equal 3. Substitute 4. 16 minus 8 would equal 8. Let's zoom in a little bit so you can see that better. Substitute 5. So 5 squared minus 2 times 5. 25 minus 10 is 15. Substitute 6. 6 squared minus 2 times 6. Well, 6 squared is 36 minus 12 is 24. So now that we have all the output values, this sigma means find the sum. So if I add, I'm just going to add use my calculator. So it's going to be -1 plus 3, because 0 doesn't add anything, plus 8 plus 15 plus 24, which equals 49. So I get a sum of 49. Yay, number 18 is done. 3 more to go. Okay, so in number 19, the right triangle, theta is our angle. It's an acute angle, and they're telling us what cosine is. So you have to know that cosine is opposite or adjacent over the hypotenuse. So if my hypotenuse is 11, so if I want to draw a little triangle to represent that over here, let's say my theta is here, my adjacent, the one next to it, the leg next to it is 6, my hypotenuse would be 11, so I need to figure out what this side is over here. So since I'm given the hypotenuse, this side is going to, I would take the hypotenuse squared minus the 6 squared would equal, if I just called this x squared. So 121 minus 36 is equal to x squared. So 121 minus 36 equals 85. So 85 equals x squared. But we don't want to know what x squared is, we want to know what x is. So if we take the square root of both sides, normally we would get positive and negative, but because it's a length, it has to be positive. So this side is my opposite. So my opposite is going to be the square root of 85. All right, so now I'm going to list those out. So my opposite equals the square root of 85, my adjacent equals 6, and my hypotenuse equals 11. So when I'm going to use those values in my expression here. So sine is opposite, or square root of 85, over hypotenuse. So that's not going to give me anything that I have to rationalize. So just put square root of 85 over 11 for sine. Tangent is opposite over adjacent. So again, that's going to put the square root in the numerator, which does not need to be rationalized. So square root of 85 over 6. Your cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, then the cosecant is hypotenuse over opposite. So if I put the 11 over the square root of 85, I will have to rationalize that denominator. So 11 over the square root of 85 would just equal 11 square root of 85 over 85 when I rationalize the denominator. Secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. So the hypotenuse is 11, adjacent is 6. So 11 over 6, or it's just the reciprocal of cosine. And then cotangent is the inverse of tangent. So if I flip the tangent, I would have 6 over the square root of 85. When I rationalize that, I'll have 6 square root of 85 over 85. So that is my cotangent. Almost done. All right, so in number 20, we're converting from degrees to radians and radians to degrees. So to do that, we're going to multiply by either pi over 180 or 180 over pi. So if you're given degrees, you want to put the 180 degrees on the bottom and the pi on the top. And then you can multiply across 225 pi over 180, but then you want to reduce, you have to reduce that 225 over 180. And again, the easiest way to do that, I mean, you could divide both of them by 5 and keep reducing, or just take 225, hit ABC, 180 in your calculator, hit equals. It does give you a mixed number, so if I take second ABC, hit equals 5/4. So that will give me that.
Andrea Whitfield, if you're still in the building, please come to the main guidance office. Andrea Whitfield, please report to the guidance office.
Sorry about that interruption. So we end up getting 5 pi over 4 is equal to 225 degrees. Okay, the next one is in terms of radians. Oh, so this is, we probably should say radians, because it is a unit of measure, radians. So here we're given radians and we're trying to convert to degrees. So multiply by, since the pi is in the numerator, we want the pi to be in the denominator to reduce it or cancel it out. That means the 180 has to be in the numerator. So that will reduce, and then we can multiply across, or we can reduce, let's see, the 8 and the 180 I think reduce a little bit, but let's just multiply across. So 5 times 180 equals 900 over 8. Does that divide by 8 evenly? 112.5. Good enough. So it equals 112.5 degrees. So I just plugged that in the calculator. So 112.5 degrees is 5 pi over 8 radians. And then last but not least, we have a complex fraction. So you need to make this numerator a single fraction. You need to make the denominator a single fraction. So if we just look at the numerator, I'm going to write this a little bit bigger down here. So I'm going to rewrite my numerator as 15 over 1 minus 2 over x. So that's my whole numerator. My denominator, x over 5 plus 4 over 1. I need to get a common denominator in my numerator. So if I have a 1 here and an x here, I need to multiply this fraction by x to make the denominators the same. So now that they're the same, 15x minus 2 would be my I can combine these fractions, so 15x minus 2 over x would be my numerator. My denominator, I have a 5 here, I have a 1 here, so if I multiply this fraction by 5, they'll both have a denominator of 5, which means I can add my numerators. So this will be x plus 20 over 5. Now that I have a single fraction, I'm going to rewrite this as 15x minus 2 over x divided by x plus 20 over 5. Or you could have, since you knew this was dividing, you could have just changed this right away to multiplying and flipped the second one. So 15x minus 2 over x would stay the same, but multiply by the reciprocal 5 over x plus 20. Now, since we're multiplying, let's see, is anything going to reduce? No. So we would just multiply across. If we distribute that 5, or we can just put the 5 in front, times 15x minus 2 over x times x plus 20, and just leave it in factored form. That's fine. We do have to worry about our undefined values though. So looking in the original equation or the original expression, you have an x in the denominator, which means x cannot equal 0. So this is your simplified value. However, x cannot equal 0. And if we look at the denominator here, that could not equal 0. X can also not equal negative 20. And I think that is it. Yep. And there you have it. That's your review for our integrated 3B final. Good luck.